Hey, what's up, everyone? Welcome back to the How to Learn Data Science in Python episode number 12 on the DataCamp. This is your boy James. Today, we are going to talk about how to import flat file from the web and from a session of import data from the internet in Python. So let's just dive into it.
You're now able to import data in Python from all sorts of file types. Flat files such as TXTs and CSVs. Other file types such as pickled files, Excel spreadsheets, and MATLAB files. You've also gained valuable experience in querying relational databases to import data from them using SQL. You've really come a long way. Congratulations. However, all of these skills involve importing data from files that you have locally. Much of the time as a data scientist, these skills won't be quite enough because you won't always have the data that you need. You'll need to import it from the World Wide Web. Say, for example, you want to import the wine quality dataset from the machine learning repository hosted by the University of California, Irvine. How do you get this file from the web? Now, you could use your favorite web browser to navigate to the relevant URL, point and click on the appropriate hyperlinks to download the file, but this poses a couple of serious problems. Firstly, it isn't written in code, and so poses reproducibility issues. If another data scientist wanted to reproduce your workflow, she would necessarily have to do so outside Python. Secondly, it is not scalable. If you wanted to download 100 or 1,000 such files, it would take 100 or 1,000 times as long, respectively. Whereas if you wrote it in code, your workflow could scale. As reproducibility and scalability are situated at the very heart of data science, you're going to learn in this chapter how to use Python code to import and locally save datasets from the World Wide Web. You'll also learn how to load such datasets into pandas data frames directly from the web, whether they be flat files or otherwise. Then you'll place these skills in the wider context of making HTTP requests. In particular, you'll make HTTP GET requests, which in plain English means getting data from the web. You'll use these new request skills to learn the basics of scraping HTML from the internet, and you'll use the wonderful Python package, Beautiful Soup, to parse the HTML and turn it into data. Now, there are a number of great packages to help us import web data. Herein, you'll become familiar with the URL lib and request packages. We'll first check out URL lib. This module provides a high-level interface for fetching data across the World Wide Web. In particular, the URL open function is similar to the built-in function open, but accepts universal resource locators, URLs, instead of file names. Let's now dive directly into importing data from the web with an example, importing the wine quality dataset for white wine. Don't get jealous. In the first interactive exercise, it will be your job to import the red wine dataset. All we have done here is imported a function called URL retrieve from the request subpackage of the URL lib package. We assign the relevant URL as a string to the variable URL. We then use the URL retrieve function to write the contents of the URL to a file, winequalitywhite.csv. That's it. Now it's your turn to do the same, but for red wine. In the following interactive exercises, you'll also figure out how to use pandas to load the contents of web files directly into pandas data frames without first having to save them locally. Happy hacking!
Import flat file from the web. So we got this Y quality dash red CSV, right, from the machine learning repository, and this is the S3 bucket link, and we're gonna turn load it into Panda data frame. First import function from the sub package import function URL retrieve the URL. See, retrieve the URL lib the request. Assign URL to the location. Copy and paste. Save to the locally. How to do that? Use the retrieve URL function. So what do we save over here? He did something. PD read the df save. I forgot what's that. Oh, is that like U URL retrieve? Um, URL lib request. What's the problem? That is syntax. URL retrieve. Is it weird? Let's see. So I follow what he did over here. Or import request. Import a function from the sub package. From sub package. Oh, so package from package import function. So URL lib request is the sub function, and URL retrieve is the URL dot request is the sub package, and the URL retrieve is the function. Here we go. You have just imported a file from the web, save it locally, and load it into a data frame. If you just want to load a file from the web into the data frame without first saving it locally, you can do that easily here. Appendix. In paragraph, you can use the function pd with set the first argument separate second argument. Okay. Open and read the file from the web. So matplotlib pll appendix. Could you give me 1 second? Say URL, file URL. URL, that's self-explanatory. Read the file into data frame. Yeah. Wait, what's the difference? So this guy URL, retrieve URL to this guy and save header. Here you got URL, PD data frame over here, and can you just URL step equal to kind of separate side. Really, you can do that? Why it's not comma delimiters? I thought CSV is a comma delimiter, right? But here you just get like a separate size over there. Let's add, print it out. Oh, sep. But here you see CSV and sep. Here we go. What's the problem? Acceleration. X shot. Let's see the hint. Oh, it's a read, not data frame. You not make a data frame. It's not an object. You need to read.csv. Read underscore csv. Here we go. Here and the graph. Nice. Fix asality for x-axis, y-axis is count. Next. Import non-flat file from the web. I don't know why separate is not for the comma instead of that. Maybe each row is just separated by the separation. You have load the flat file on the web. First statement, the local user pandas function will access it because it's a close relative allows you to load from all type not on the flat file. And Excel to report. Okay. Read Excel. Read Excel. To best not to open the sheet. Sheet name. Let's do big key suggestion. So print the sheet name, right? So is that Excel dot execute? I don't remember. Okay, no sheet name. sheet name. What is a sheet name? No. Over here. Are those a column name? Print the name of the sheet in this Excel spreadsheet. They will be the key of the Excel. Okay. Print head of the first sheet. Another index. Uh, print this one first. No, I don't think that's right. Forgot the syntax, guys. Let's look at that. Keys, okay, keys, because it's function, we get to do this. Okay, key, row and columns. So, access sheet using format dictionary, seed name and index. We gotta see what we have here. Sheet, right? What is the from key? Not quite sure. Oh, forgot that's the answer. Oh, so print the head of the first sheet. Use the sheet name, not the index of the sheet. Oh, he told us. Okay. So sheet name. Okay. But that's the second sheet, right? We have the first one. Good. Okay, next one. HTTP.
Congrats on importing your first web data. In order to import files from the web, we use the URL retrieve function from URL lib requests. Let's now unpack this a bit and, in the process, understand a few things about how the internet works. URL stands for Uniform, or Universal Resource Locator, and all they really are references to web resources. The vast majority of URLs are web addresses, but they can also refer to a few other things, such as file transfer protocols, FTP, and database access. We'll currently focus on those URLs that are web addresses, or the locations of websites. Such a URL consists of two parts: a protocol identifier, HTTP or HTTPS, and a resource name, such as DataCamp.com. The combination of protocol identifier and resource name uniquely specifies the web address. To explain URLs, I've introduced yet another acronym, HTTP, which itself stands for Hypertext Transfer Protocol. Wikipedia provides a great description of HTTP. The Hypertext Transfer Protocol is is an application protocol for distributed, collaborative, hypermedia information systems. HTTP is the foundation of data communication for the World Wide Web. Note that HTTPS is a more secure form of HTTP. Each time you go to a website, you are actually sending an HTTP request to a server. This request is known as a GET request, by far the most common type of HTTP request. We are actually performing a GET request when using the function URL retrieve. The ingenuity of URL retrieve also lies in the fact that it not only makes a GET request, but also saves the relevant data locally. In the following, you'll learn how to make more GET requests to store web data in your environment. In particular, you'll figure out how to get the HTML data from a web page. HTML stands for Hypertext Markup Language and is the standard markup language for the web. To extract the HTML from the Wikipedia homepage, for example, you import the necessary functions, specify the URL, package the GET request using the function request, send the request and catch the response using the function URL open the URL, package the web. To extract the HTML from the Wikipedia homepage, for example, you import the necessary functions, specify the URL, package the GET request using the function request, send the request and catch the response using the function URL open. This returns an HTTP response object which has an associated read method. You then apply this read method to the response, which returns the HTML as a string, which you store in the variable HTML. Finally, you remember to be polite and close the response. Now, we're going to do the same. However, here we'll use the requests package, which provides a wonderful API for making requests. According to the requests package website, requests allows you to send organic, grass-fed HTTP requests without the need for manual labor. And the following organizations claim to use requests internally: Her Majesty's Government, Amazon, Google, Twilio, NPR, Obama for America, Twitter, Sony, and federal US institutions that prefer to be unnamed. Moreover, Requests is one of the most downloaded Python packages of all time, pulling in over 7 million downloads every month. All the cool kids are doing it. Let's now see requests at work.
That's cool.
Here you import the package requests, specify the URL, package the request, send the request, and catch the response with a single function, requests.get. And finally, you apply the text method to the response, which returns the HTML as a string. Okay, that's enough out of me for the time being. Let's get you hacking away at pulling down some HTML from the web using GET requests. Get coding.
Cool, let's do it. Perform HTML request in Python using URL lab. Okay, we got this HTML, HTTP link, import package URL lab request. URL open request. Request. So what's the request do? We will ping the very DataCamp server to perform a GET request to extract information. Okay. So URL, so basically ping that, right? Send it, catch a response. Respond equals to request dot, let's see, URL open. Import URL lab request and request syntax from. What's the problem? This is a package, right? Or import. Oh, from package. See, package is always at the end. You specify the function first. Here we go. What? Still not right? What I did here. Let's go back. Pandas from SPD. Okay, not this one. Not this one. Request import. Oh, import function from. Oh, from import. From the sub package import something. That's the syntax. From sub package import something. Right? And here, what do we have here? So add header, add unrestricted data fragment, get header, get message, get header proxy, all kinds of stuff, right? What do we need here? Send a request to capture response. We don't have URL open here. Is that so? This is what is this one? Object. Okay, it's object request object. If I understand right, URL open. This is not defined. Let's see the hand. Presence argument URL open. Right. Respond. Response. Not response. Response is not. What's the answer? Missing a E. What a shame. Here we go. Print HTTP request result in Python using URL lib. Link, right? And the catcher response uses such response, HTTP clean HTTP response, object question. But it was this response. Send the response to catcher response. Response equals to you open I request execute the extract HTML. HTML equals to read. We can read this response. Send the request to catch a response. So send the response to print. What is HTML? Let's see the whole what's abbreviation. Hypermarket text language. Okay. Close. Read is not defined. What do you mean? Is that a function? Here we go. Okay. Perform HTML request in the Python user request. What's the difference? Those three. So perform HTML request in Python using library URL lib open type close. Second one is a print HTML request result in Python using. Third one right now is just the perform HTML request and the user request. It's quite similar, I think. Record only to yes. It's not get. Oh, I think it's just request. Get URL request, send the request and catch response R. Fix response in tags. Tags equals to part history. First rows and see what we have here. Tags. Yes. Tags. String object is not called. Function, right? Text is not defined. Text is attribute. See? Text is after R and return to the work which is a string to return text. It's a hint. I.text not function. Like this. Oh, okay. That's a type before. Wait, it's not right. Hmm. Attribute not a function. That's interesting. You guys know what's the difference between attribute and the function? Let's see. Python attribute classes. Those two can divide the attribute name. Other can do is attribute method. Method is a function of the also function. What is attribute? Data attribute attribute a value that is compatible with another object using something. It's a variable that is compatible with another object using action can be inside values in the object to show article transfer between different classes. It's kind of not clear, but we figured out on the way. Okay, let's see. Next, scraping from the web.
Wow, you've just scraped HTML data from the web, and you've done so using two different packages, URL lib and requests. You also saw that requests provided a higher level interface, in that you needed to write fewer lines of code to retrieve the relevant HTML as a string. You've got the HTML of your page of interest, but generally, HTML is a humble jumble mix of both unstructured and structured data. A few words on these terms. Structured data is data that has a predefined data model or that is organized in a defined manner. Unstructured data is data that does not possess either of these properties. HTML is interesting because, although much of it is unstructured text, it does contain tags that determine where, for example, headings can be found, and hyperlinks. In general, to turn HTML that you have scraped from the World Wide Web into useful data, you'll need to parse it and extract structured data from it. In this video, and the next few interactive exercises, we'll provide a brief introduction to how you can perform such tasks using the Python package Beautiful Soup. Let's now check out the package's website. The first words at the top are, you didn't write that awful page. You're just trying to get some data out of it. Beautiful Soup is here to help. Since 2004, it's been saving programmers hours or days of work on quick turnaround screen scraping projects. Firstly, a word on the name of the package. Beautiful Soup? In web development, the term tag soup refers to structurally or syntactically incorrect HTML code written for a web page. What Beautiful Soup does best is to make tag soup beautiful again and to extract information from it with ease. In fact, the main object created and queried when using this package is called Beautiful Soup, and it has a very important associated method called prettify. Let's now see Beautiful Soup in beautiful action. Once again, you use requests to scrape the HTML from the web. Then you create a Beautiful Soup object from the resulting HTML and prettify it. Printing the prettified soup and the original HTML, you can see, for example, that the prettified soup is indented in the way you would expect properly written HTML to be. You'll explore a few of the methods that you can apply to your soupified HTML in the following exercises, such as title and getText, which extract the title and text respectively. You'll also work with the soupy method findAll in order to extract the URLs of all the hyperlinks in the HTML. These are merely a few of the many methods existing in Beautiful Soup to extract data from HTML. If, after completing these exercises, you find yourself thirsting for more Beautiful Soup, there are plenty of great resources on their website. Okay, Now it's your turn to jump into the deep end of the proverbial soup bowl. Happy hacking.
Cool, let's do it. Pass HTML with beautiful soup. This is the link, right? Import request, import package. From package S4, import the function beautiful soup. URL equals to the link. I equals to requests get URL and here HTML equals to extract. How do we extract text attribute? Ext, right? Create a beautiful soup. A function HTML first. From here, those are attributes. So the function should be EAU for soup, right? Pretty soup. Pretty soup. Use a method. Error session lies online in the history log move to new session. What's that? Space. Is that a function or that's attribute? Predefine. Print AT soup. Guess so. Good. I don't know what's that warning about. Like, oh, you can see that's okay. Cool. But yeah, let's keep going. Turn web page into data using beautiful soup. Okay, import that. HTML that again. Create a beautiful sub object. Soup equals to same code and GM code already been created for first beautiful soup design. Get the text first. Convert R URL request get the request and then turn to text and then EAU beautiful soup. The title equals to soup. That don't have here. That's a new method. Keeper title. Stroke text range zero using but I don't have this method. Get text. Get. Yeah, that's the problem. That's what I have. That's what I have here. Get text. Oh. Get Guido test. What is that? Oh. Subtitle. Okay. Ah, so we get the title first and then in the picture title. Okay. Get the. Do you really get the title? Oh, you get the tags over here. Oh, you get it. Wait a second. Oh, you get the title first, then print title and get the text. Is that what you're saying? Title, get text, and the print text. Okay, that's what you're saying. Did you currently define the variable get title? Oh, here. XT. There we go. Turn a web page into data user before to get the hyperlink. Find all your find all. Use the method find all to find all the hyperlinks in soup. Remember that the hyperlink is defined by the HTML tag A. Store all the results in variable A tab. Pull the soup get URL tags. Print HTML. From all A tags. Soup. First. Find all method. Expressions. What's that? Um, tags. Using format independent. Here's not defined. Okay, let's see what's the difference. How about we change to find out find out. Oh, okay, the same. It's a conformity. So it's the same. Check where you find out teachers first and first argument. We need argument? What is argument? Find out we need argument. Oh, this is fine. Okay. Good. Not nice. So let's see. I guess it's conclude today's episode, and
In this
next
chapter,
episode
you'll explore
we're gonna talk about the introduction of API and JSONs. So I hope you enjoyed today's episode, and I'll see you next time. Peace.